Okay, so let's go in and talk about how to do a really simple version of a chi-squared test using some real basic biological data. So I am replicating the idea of a camera trap study, so this is why I have like photo ID here, but this could really be for anything that is comparing a couple different sites and doing real simple versions of this data and trying to see whether or not these two things are related, right? Whether in this case I'm looking at location, whether it's a lake or a forest, and then I'm asking, are there coyotes there? Yes or no, right? So real simple, yes or no. And I want to see, is location informative to where coyotes are, or is coyotes, do they have some association with the location, right? Don't care about the direction of the relationship, just is there a relationship between these two? So the first thing that I want to do is I need to go in and actually convert this long list of data, right? I've gone through and made this data up, but if I am recording photos and like processing these photos, I'm going to spit them out in this kind of format, but that's obviously not the way that I'd like to use that in a chi-squared. So the first thing that I'll do is I'm going to actually select all of my data. So I'm going to go to the very top and I'm going to press Control Shift and hold Control and Shift down. And then using my arrow keys, I can actually go to the right and it actually selects all of the data columns, and then go down and it selects all of the rest of the columns. So now I have all of my data selected. And I can go to Insert, and then I could design my own pivot table if I want, but I'm just going to use the recommended pivot tables because this is really easy. What a pivot table does is it's basically summarizing the data that I have put in already. So it can change the format for me so that I don't have to go through all the trouble of tallying things or counting things. So what this is going to do is it's going to create a really simple version of this data, and it puts it always on a different sheet. I don't particularly care to operate on this sheet, so what I'm going to do is I'm actually just going to put everything on this first sheet. So I'm going to copy my pivot table and then put it over here, and I'm just going to paste those values so that you can actually see what that is, right? So just to get things out of the way a little bit. So what this is I've essentially, when I'm making a chi-squared test, I have made my observed values already, right? So I observed in 28 total pictures that I was taking of a forest and 30 total pictures of taking in a lake environment. Are there coyotes there or not, right, in these camera traps, right, in these triggers that I see, right? So this is, your data might be formatted in a different way. You might be asking different questions. This might be not the way that you would want to set something up because of the structure of your study or the structure of your questions. But so this is just a real simple, clean and dirty version of this. Well, the other thing that I need to do is I need to produce an expected value, right? So if you remember, the expected value is the observed and expected value. What chi-squared is essentially doing is it's looking at the difference between this, right? So if you look at the kind of standard chi-squared test, this is looking at the sum total of observed minus expected divided by expected to the second power, right? Squaring it. That is the sum total of all of those values is what chi-squared actually is. So we are not going to do that because that is a waste of time. We have Excel to do this for us. So what I need to do first is I need to produce my expected values. So I have to do a little bit of calculations. So I'm just going to recreate my observed table with forest and lake and yes and no. And I need to fill in what I would have been expecting if there was no difference between these, right? This is not even, right? I didn't take the even number of pictures between forests and lakes, and I didn't have coyotes present in 50% of pictures. So this is obviously not going to be equal numbers on each of these expected values. So rather than trying to like type this, to calculate this on my own, I'm going to make Excel do it for me. So if I'm in my forest no column, I'm going to press equal sign, and that starts generating a formula. So it's going to start doing a really simple formula. And what I want to do is I'm just going to take the column total, multiply the column total for no and forest by the row total, and then divide that by the overall total. And if I hit enter, then it does the calculations for me. I don't have to have written that down somewhere else and then copied and pasted it into Excel. I don't even really have to type all of that stuff in again. I can just Control-C to copy that value, and then C-V it somewhere else. Now, obviously, that breaks this value because I'm actually looking to shift all of these over. I wanted to shift the yes totals over because I'm not looking at the no column anymore. But you can see these red and purple columns, those are also shifted. So what I need to do is I need to adjust these and bring them back to where I actually want them to be. Oops. So I click back into that formula. I can then drag them over to where I actually want. Hit enter, and that does the calculations for me. Ways that I can get around this is I can kind of reduce the amount of dragging that I have to do. If I put the dollar symbol between all of these values, right? So if I put $H as in column H, $6 as in row 6, now it's actually going to not shift this anymore. So if I copy and paste this, I'm still going to have to do a little bit of shifting, but it's not going to be as bad. So it's still going to keep that purple column in the right spot. I just have to do a little bit more of the shifting, right? So now I have to shift this other one over so it's actually looking at a real number. And it's not looking at the yes column, it's looking at the grand totals column. But you can see that that 58 number is still staying in the same spot, so I don't have to do all of the shifting. Now I have my expected values, and what I could do is if I were a masochist, I could go in and actually do this calculation and add up all of the chi-squared values for all of those different areas and do a degrees of freedom comparison and that kind of thing. I don't want to, right? So I'm just going to make Excel do it for me. Excel has this handy little sheet that actually does this automatically for you. If you create your a new formula by pressing enter in a blank column, if you type in chi.square, oops, I have to chi-square, not chi.square, and test, what this is doing is it's actually sending you out the p-value from a full-on regular chi-square test, right? So if you've actually typed in and did all of those formula and used this formula, it would actually give you the same value that it's about to spit out now. So what we're going to do is it actually tells you what it's expecting you to put in here. So it's expecting to put in the observed values. So I'm now going to copy and highlight all of those observed values. So it's going to show F4 colon G5, right? So because I've selected from the F4 to the G5 area. And then following the format of the formula that's expecting, I'm going to hit comma, and then I'm going to select the expected range and then end my value. So I could probably hit enter, but just to be safe, I always try and end my, close my parentheses and then close it and then press enter. And it spits out the p-value. This is essentially the p-value of a chi-square test. I don't have to go and look up the degrees of freedom tables or anything like that. I've already had the work done for me. Now, you remember that if the p-value is under 0.05, right, that's kind of the cutoff value for most scientific studies in biology. If the p-value is under 0.05, then I would agree that there's probably some association between these two things. A p-value of 0.71 is obviously not under a value of p5, it's over it. So I would say that there's not an association between these. Now, this is an association based on me just making up fake data, right? So if I had real data, maybe that might actually change, right? So maybe there might be some association. That is how you go about using a pivot table to really quickly summarize your data so you don't have to do as much of the hard work of adding things up, and how you go about really easily doing a very simple p-value. So that is all I've got for this. Pretty simple stuff.